transferring data to and from HDFS. So what motivates me to pick this topic? In pursuit of data warehouse optimization, many organizations are embracing Hadoop and they're trying to offload existing data warehouse data, which is more redundant or maybe backup data, into HDFS. By doing so, they would like to realize the cost benefit as well as have to have access to more distributed file system and more capacity, and also they could expect to take advantage of new data types such as clickstream and social and mobile data and have a competitive advantage compared with their competitors. So what we are going to see in this slide deck, what's ahead. So I'm going to talk about Sqoop architecture, and to demonstrate the capabilities of Sqoop, I considered a use case to predict healthcare cost buckets, and I'm going to talk about that. Also, architecture and technologies that I have used in this project, and detailed implementation and issues that I have encountered. Sqoop, what it is, what we can do with it. As we see here, it's a distributed and most reliable service for efficiently moving large amounts of data across HDFS and relational data sources. It has many capabilities to import the data and export. Just like any ETL tool, we can see incremental updates or incremental loading the data on joiners, kind of those things. Having said that, let's look at Sqoop architecture. So as we see here, we can create a Sqoop job which it will be stored internally in a metastore. This can be shared across multiple clients to have same job. During incremental loads, it's going to have the last imported values, and next time when we are capturing the data, it's going to start from the last import rather than going from the beginning itself. So when we submit a Sqoop job, it's going to read database catalog tables and going to generate map reviews, Java classes and jar files, and then going to initiate the map reduce jobs, which eventually pick the data from relational data sources and move to HDFS platform. How we can demonstrate the capabilities? So I choose a use case on healthcare cost buckets predicting, and let's see how our big data technologies helps insurance companies to accurately predict the future cost buckets so that they can manage the cost most effectively. As part of the data side, I have used CMS data, Centers for Medicare and Medicaid Services, and they have a huge repository of data. For this purpose, I have considered only beneficiary summary data, which has around 41 MB, and as you see here, 7 million records of data, patients data. And it has various important independent variables like age, date of birth, disease conditions, and cost for various years. So from the architecture perspective, I have loaded the data into MySQL database. Using Sqoop import facility, I loaded the data into HDFS platform, and I have transformed the data using Spark, Scala, and then in the later stages, I feed this data to a decision tree classifier model. Eventually, for 2010, I predicted the future cost buckets. Once I have that data, using Sqoop export facility, I exported data into analytics database, where we can do some kind of reporting. In this case, I have used this data to compare what is my actual and predicted cost buckets. Following is the technology stack that I use: VMware and Cloudera distribution, Sqoop 1.4, and Spark, MLlib, and Scala. And also use Plotly for plotting the outcomes. So let's look into each of these aspects. As a first step, I loaded the data into MySQL. So as you see here in the data model, I have landing and target areas. So I consider 3 years worth of beneficiary summary file and loaded into landing area as step 1, and then loaded the same data into target area. During this process, I also added 2 additional columns to the target area, which is year and create date. As you can see, so I use this create date to incrementally load the data into HDFS, which you can see more details in the report section. So the next step that I have used is import the data into HDFS. So the first step is, I created a beneficiary Sqoop import job. As you can see here, I created a job, Sqoop job, which, as we discussed earlier, it's going to reside in the meta store so that Sqoop clients can access this one and take advantage of the last value, which is the last imported value, which is coming from this create date itself. So let's look at this statement, what we are doing here. So I created a job beneficiary. What it's doing is it's doing import job connecting to this database MySQL, connecting to this server MySQL, and the database is ClampsDB. And here we are providing the username and password and the table which I would like to add to HDFS. And here I'm specifying its incremental append. And the split by column is this unique member ID. This is very useful and this is a very important column that we need to add. Based upon this, Sqoop is going to decide how many map jobs that he has to run. And lastly, you can see here, I'm specifying the warehouse directory, client/many, and it's going to import all the data into this particular directory. The other option being, I can specify the target directory, where in that case, it's going to create the directory all the time. And if there is directory already exists, it's going to complain saying that, okay, directory already exists, the job is going to fail. But if it is a warehouse directory, it's going to create underneath without any complaints. So this is the job that I created. So now we need to execute the job. So here I'm specifying the command Sqoop job execute beneficiary. So the first step, what it's going to do is it's going to read by reading database catalog tables. It's going to generate MapReduce Java code. As we see here, it's created the class files, jar files, and the .java file. And this is kept under the temp Sqoop Cloudera directory. As for the MapReduce job log, we see here 50 MB of data is moved from relational database to HDFS. It took about 40 seconds. So at the end of the MapReduce job, so it's created this warehouse directory clampsDB underneath. It created by the table and kept all the files. So as we see here, it instantiated 6 MapReduce jobs. 4 of them are populated with the data. Let's examine the content of the data. It has year, create date, and the unique member ID, date of birth, sex, and all other disease conditions. And also we are going to see here the payment made by Medicare. So as you observe here, we don't have a cost bucket here. We are going to derive that in the subsequent sections. So once the data is in HDFS, we're going to transform the data, which can be sent to decision tree classifier. So in this case, we have this trend data set 2008 and 2009 and 2009 and 2010 for test data sets. So here I'm going to submit this Spark job, which is going to take my class name, job names, and year 1 and year 2 input file and output file format. And as an output, I'm going to see here various columns like which is the transform data. We are going to see here 2008 cost bucket and 2009 cost bucket, which is a dependent variable which we are going to predict in the subsequent sections. So I'm building this decision tree classifier by passing 2008 and 2009 dataset as a train and predicting 2010 cost buckets. And once again, here I'm going to submit this box job, which is going to take the class, the trend data, predicted data, and output file. As you see here, the output file, it will have the last two columns if you observe. So the last column being the predicted cost bucket, and before that one is the actual one. So now we want to see what is the model accuracy. Before we do that, we need to export this data to relational database. In predicted cost buckets, we're going to export that from HDFS to Analytics DB, taking advantage of Sqoop export functionality. So here I'm going to specify the directory which we need to export and the table to which we need to keep this data. So in this case, I'm going to keep this one Medicaid cost bucket table. So it's going to load it into the batch mode, and once we submit this query, Sqoop is going to create these MR jobs. It's going to create those .java, .class, and jar files. And in 38 seconds or so, it's loaded 7.5 MB of data into this Medicaid cost bucket table which exists in Analytics DB. So as we verify here, so it has total, the record count is matching with what we see here in MR job. So what's next? So I imported this data into Plotly to visualize how it compared with the actual cost buckets and how my model predicted. As we see here, it's pretty close match. And Sqoop is a powerful utility. Many use cases they can leverage to offload expensive relational data to HDFS platform. And as we see here, Sqoop has many connectors to many of industry-leading relational databases. And also, one thing that I can other side note is Spark is catching up on different models. Especially I was looking for penalty matrix and those kind of things, it's still catching up. Once Sqoop 2 is stabilized, I'm going to export those functionalities. And also the decision tree classifier, I'm going to include diagnosis codes to have an accurate or more precise model. And also we could leverage D3 for data visualization with a seamless straight integration with Analytics database. So some of the references worth noting here is Centers for Medicare and Medicaid Services for their source data, and also Analytics Edge. This course, it gave a deep dive into various analytical techniques, and also books like Advanced Analytics with Spark and Apache Sqoop Book are noteworthy. Summary. So tight integration of Sqoop with the Hadoop ecosystem and relational sources, and having a strong committed Apache community and their commitment to develop Sqoop 2. Having seen all this, one is going to play a major role, especially in the use cases like backup storage, complex data processing to offload data from relational data sources to HDFS. By doing so, organizations they can leverage huge cost savings and increased processing power by moving data into these distributed file systems.